Today we're talking about compound inequalities. Compound inequalities are two inequalities that are joined by the word and or the word or. So for example, if we have x is greater than or equal to -5 and x is less than or equal to 7, this compound inequality can also be written as -5 is less than or equal to x and x is less than or equal to 7. Now we can graph this inequality, this compound inequality. So we have -5 and then we've got 7. If x is greater than or equal to -5, that means there is a closed circle on -5 and our line is pointing to all the numbers that are greater than -5. If x is less than or equal to -7, we have a closed circle on 7, and x is all the numbers that are less than 7. So it's going in the left direction. It's pointing to all the numbers that are less than 7. That means that our graph is connected. This means that the numbers that make this compound inequality true are -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, and 7. If we have to graph the compound inequality x is less than -3 or x is greater than 7, can we create our number line? -3 and 7. Now x is all the numbers that are less than -3. So open circle on -3, and our graph points to the left, all the numbers that are less than -3. Or x is greater than 7. Open circle on 7, and x is the numbers that are greater than 7, so our graph points to the right. This means that the numbers between -3 and 7 do not make this compound inequality true. So it's either the numbers less than -3 or the numbers greater than 7. We need to solve and then graph. -4 is less than r minus 5, less than or equal to -1. Right here, r minus 5 is what they're sharing. This means we can rewrite this compound inequality as two inequalities. -4 is less than r minus 5, and r minus 5 is less than or equal to -1. Why do I say and? Because of the way it's written, I know it's an and. If this inequality were to be an or, we would have had the or in there, in the problem. So here we go. Now that we've rewritten it as two separate inequalities, we're going to solve each of these. This means +5 to both sides. 1 is less than r. And we have to solve this other one, +5 + 5. R is less than or equal to 4. Can we graph this? And 4. So on 1, this is an open circle pointing towards the right. And on 4, it's a closed circle pointing towards the left. So they meet. Solve and graph -6 less than or equal to 3x less than 15. So what are we sharing? 3x. So we're going to write this as two inequalities. -6 is less than or equal to 3x, and 3x is less than 15. Going to solve both of these. So we're solving for x. Divide by 3, divide by 3. -2 is less than or equal to x. Divide by 3, divide by 3. less than 5. If we graph this, 2 and 5. If we have to solve and graph 4b plus 3 is less than negative 5, or negative 2b plus 7 is less than 1. So there's an or here. Do we have a mental picture of what the graph is going to look like? Okay. So now we're going to solve each of these individually and then graph. 4b is less than negative 8. We're going to divide by 4 on both sides. B is less than negative 2. Or we're going to solve the other equation, inequality, minus 7 on both sides. Negative 2b is less than negative 6. Divide by negative 2. B is less than 3. So when we graph this, yes.
There, you have to switch this out because you divided by negative.
I do. Thank you for catching me. I do. Thank you. Anytime you multiply or divide by a negative, you flip the sign. So negative 2 and 3. B is all the numbers less than negative 2, or B can be all the numbers greater than 3. Any questions?